All right, we're going to start the lecture on deep learning. So initially, with deep learning, we'll try to understand the concepts of neural network. So once we understand the basics of neural network, so I'm planning to take you to the implementation of a simple neural network, and then we will jump into CNN, a very important neural network which you can use for image processing, image understanding, other things, and also later for RNN. All right. So let's now see what is basically a neural network. So it's very important to understand the origins of a neural network, and this concept is nothing new. This was basically found out a long time back, and as you can see here in this image, right, uh, this idea of neuron is basically uh, identified the biologist, because we have this the neuron in our brain. So the same concept is being used in neural networks. So this is a basic neuron where you have this idea of connections coming in, and there's a processing unit, and then there's output. So you have billions of them in your brain, and when you have a kind of network of these neurons, right, so you can get things done by using these neurons. So as an example, if you see someone, you get a signal travels through these lines of neurons. So once it gets trained, you can reuse it for different purposes. So basically, that's where the origins of neural networks came into being, right? And this was even computer science. This was created, invented long time back. I can remember it was in 1950s or 60s, but it was not widely used because of the limitations of the computer. But now we are living in a time where we have enough computing resources where we can build neural networks pretty easily with all the resources which are available, right? So next we'll try to understand the structure of a neural network or the parts of a neural network. So if you sorry, one second. Um, if you look at the structure of a neural network, you can find three major categories. First one is the input layer, and of course here you will find the output layer, and in between you can have multiple sub layers, normally we call it as hidden layers. So if you want to identify you could do classification of a picture of a dog and a cat, right? So you have to feed it to the neural network, and then you can get the output as a binary classification where it's a dog or a cat. Or if you want to get numbers, so you can basically input all the numbers or a number, and you can get output. You can have 9 or 8 neurons to explain whether it's a 0 or it's a 1 or likewise. So that's what you understand, the structure of a neural network. So, and very important to understand inside in the hidden layer. So here in the hidden layer, you have the more accurate the neural network will be, right? So when you have more hidden layers, so it can have more than two, then you'll have better accuracy levels of the decisions that you take from the neural networks. And those nodes receive information from the previous layers node. So one node will receive information from the previous node. That's how it works. And basically, you have something called a weight and a bias. So those two things will be used to train the neural networks. So those days, early days, there was this feed-forward networks. So that's where the base concept came from. Now we have different types of neural networks altogether. So when you train the neural network, these are the two parameters that you are going to train, or you're going to calculate when you want to find a fixed neural network for your problem. So it's like called a model fitting. So that will do to understand how the neural network to be trained. And then if you look at different types of neural network, there are a lot of types of neural networks. And if you have to understand, if you look at the very basic type of neural network, right? the most simplest type of neural network is called the perceptron. So this is the perceptron. So it's the simplest and oldest model. So basically what you do is take some inputs, right? So you get some inputs and then basically sums it up, and you use something called activation function. So you can use a activation function. There are different types of activation functions. One called sigmoid, and ReLU, and several types of activation functions. So it basically converts your inputs into output, right? So basically this is the simplest type of neural network, which is called the perceptron, right? Then of course, one of the very famous type of neural networks, which is called the feed-forward network. So okay, page. So feed-forward network. This approach basically originated from 50s. It works is described basically with where all nodes are fully connected nodes. As you can see, all the nodes are fully connected nodes. Every node is connected to the other nodes. Activation flows from input to the output without back loops. So there's no back loops here. It's basically directly going forward, and there's one layer between input and output. So there's only one hidden layer in a feed-forward network. So, and also for training this feed-forward network, they used a method called backpropagation. So they use a technique called backpropagation. So we are not going deep into the theory part of this, but in the normal AI course, not in a machine learning course, but the AI course, you will understand this feed forward and also backpropagation and how it works. Right, and then we'll try to look at different types of network, and this time this is called radial basis network, or RBF. They are also feed-forward networks, and they use a special function called radial base function for the activation function. Normally we use logistic function, but here we use the radial function. Logistic function basically maps arbitrary value to 0 and 1 range, basically yes or no. A radial function answers the question how far we are from the target. So that's basically more of an approximation problem when it comes to radial based functions. So this is also quite famous, right? So radial functions. So and then the next one, which is quite interesting, right? This one is called deep feed-forward networks. So this was invented in early 90s. So these are again feed-forward network. So, but as you can see here, all connected, right? So all connected feed-forward. This deep feed-forward ones, you have more than one hidden layer. So that's one of the major differences from a feed-forward network. And also, yeah, so these are more effective. Yeah, so but there are better implementations of this. So we might not use most of the deep feed-forward networks right now. And then let us check a very neat type of neural network, which is called the recurrent neural network. Probably have heard about this. These are famous these days. This is quite famous, and the early type of this type of networks called Jordan networks. It hidden cell received its own output with a fixed delay on one more iterations. Right, so that's what they do. There are many variations passing the state to input nodes, variable delays. So they'll be having some variable delays here in different nodes. So this is basically the recurrent neural network, and this type of neural networks uses the special types of node type called memory cells, which is again used in this concept of long short-term memory, which we will probably look at later on, right? So that's also quite interesting type of neural network. So likewise, there are plenty of neural networks. I won't be continuing this discussion for a long time because it might be boring for you to listen to different types of neural networks, but we'll try to use some of these neural networks and try to get things done in the lectures to come, right? Yeah, so basically these are the things that you're supposed to know. And when you talk about a neural network, so you will have a structure of an equation like this. So can go from I equals 1 to n, and then so basically you can yeah, rather looking at this, we'll try to understand that there are these activation functions, right? And also if you look at the inputs, right? So if you look at the inputs, there are several inputs to a neural network, I1, I2, I3, and then those are basically handled through weights, weight 1, weight 2, weight 3. So and then that will be handled through activation function. So the same applies here, right? So if you do use as a sigma for all these inputs, so we can have multiple inputs, which is an I, right? And then you can have multiple weights. Uh, here multiple weights. Okay, so there should be a multiplication here, and then we'll have bias. So this is basically the equation that we use for a neural network. All right, so now what we try to do is, rather than going through a lot of theory, so we try to implement this, right, using a kind of a algorithm, right? So to do that, I'm using I can use Keras as the main library. So Keras is quite easy to use with neural network. And for Keras, there should be a backend. So there are several options. You can use TensorFlow from Google, right? That's probably the one that we are going to use, and more frequently used option. And Microsoft is having the CNTK platform. So Microsoft, so that's also possible to use it Keras, and there is the other famous version called Piano also is there, so you can use that as well, right? So those are the three options. So we are going to use Keras and TensorFlow. So I'm going to use PyCharm as the IDE, and I have already installed Keras, TensorFlow, and other basic tools. So I did a video on how to basically implement those things. So let's start developing our neural network. All right. All right. So I will create the Python file. So I'm planning to use a basic neural network. So I'm going to say n network. Dot py. So it's a Python file. Okay. Oops. Okay. So, okay. So now I'm going to write the code. So initially I need to get the NumPy library, and I might need the matplotlib. I might need the pyplot as PLT. So those are the two important ones initially. Then I of course need Keras, and when you use Keras, make sure that you need to use TensorFlow as well. Yeah, so those are the two major three major imports that you have to do. So the next what I'm going to do is I'm going to check the backend that I'm going to use. Actually, I have installed only the so there's a function called backend. Yeah, so just we'll check what is the backend which used by Keras here in yeah. So so it should be TensorFlow. Yeah, so it uses TensorFlow backend. So yeah, so that's fine. So that's as expected. So I have to use TensorFlow, and then what I'm going to use. I need to okay, so this is actually the message, so it took some time to, so it's a bit slower than expected, it's okay. So I need the keras to be used here, so let's check. We'll look for keras data sets, so I might need a data set here. So there are several keras data sets available. If you go to keras.io site, you will find several data sets available. Okay, so there's this data set called CIFAR10. It's a small image classification. So 50,000 images, 32 by 32, so we can use that one. And then it's almost the same, but this one is a little bit different. There are 100 categories. Okay, and then you have IMDb movie review sentiment classification. Though this one also we'll try to do later. And then Reuters Newswire, and then MNIST database for handwritten digits, and then the fashion articles. So this is what I'm going to use here. So there are 16,000 images, 20 by 20 pixel. Again, this is not very large amount of pixels in the image, so these are very low resolution images. And there are 10 fashion categories. So you see t-shirts, which is label 0, trouser, pullover, dress coat, uh, sandals, shirts, sneakers, bags, and ankle boots. So, and then along with test set of 10,000. So we have 60,000 as the training set, and test set is 10,000. And data set can be found in drop replace on MNIST. So this is also an MNIST data set. And if you want to use that, you have to use these two commands. So I'll copy that one. And of course, there are other data sets as well. Yeah, so those, these are the major data sets that this supports, right? So if you want to do some interesting practicals, you guys have to use some of these data sets. So let me copy the data set, this command. All right, so from keras data sets, import fashion MNIST, and then so I have the extrain variable, ytrain variable. All right. Okay, so now of course you have the extrain, that is the training data set. These are the inputs, these are the labels, and the test data set. It's loaded, right? So let me now run this. So normally when you run this, it will download the data set to your system. So in my case, actually I ran this earlier, so I think already the code is there, so dataset is there, so it will not download it again, right? All right, so now, so the basics are covered. So I have got my data set. So let us check on a bit about our data sets, right? So just you'll get some parameters about data sets. So let's examine the data sets. Okay, so I might do a print on extrain. It's pretty simple extrain. Extrain. Okay, and I will check for the shape. Yeah, so just to get idea about the shape of the data set, training data set. At the same time, I can check the Y data set also, or the output. So as you can see, you have 60,000 data elements, rows, and then These will be the sizes. Alright, I will check for y as well, and also I will check for the test data set. So we should be test. Okay, so I will check the properties of data sets. Alright, so why it would be having only again 6,000, so you don't have any dimensions listed, but the test data set we have 10,000. So we have 10,000 rows here in the testing data set. Alright, so that's clear. So I don't need these things printed all the time, so I'm going to comment these ones. Right. If you work with a notebook, you don't have this problem, but here I will do that. And just I will look into my data. So there's a function called matchShow, right? For that I will check, I will use okay, I will try to get the one of the data sets, one of the data elements from the data set. So I'm going to print this using the match4. So then I'm going to make it show, and let's see the output of this. Okay, it might take a bit of time. So similarly, I can check what will be the label. Okay, so this is as you can see, we have the pixels 28, 28, and what you see is a boot. It's a boot. Okay, so if you can see here, ankle boot. That's ankle boot. Should be ankle boot. So I can check the Y also. I can check the Y also. So I'll do print on that as well to check. So it's just a value. So I can do print on Y train, and again this is also same index. It is 0. So now we check. So I don't need this anymore. I run in this one, and I run this. Okay, so it's running. So let's stop and run. When would you like to stop? Okay, so let me close this. Okay, now it's running. So I can check what is the Y value. So ideally it should be 9, right? So according to here it should be, label should be 9. So we check whether we get 9. Yeah, so my system is quite slow. So we'll wait for the, okay, 9, it's 9. So basically that shows that is correct. Okay. Right, now I need to get the data set, and then I have to build a neural network, right? So initially, to feed the data into my neural network, I have to set up the data set. So the data set is basically, if you look at the data, I can do a print and see this. If I check xtrain, if you get this and check, I don't need this now. So you can see you have big data set here, and also the values ranges from 0 to 255. If you get a 1 pixel, the values are changing from 0 to 255. So you can see get values like this. So this is not going to work for our neural network model, so we have to normalize this. Okay, as you can see, the values are ranging from 0 to 255. So this will not work. So what I'm going to do now, I'm going to, I might need this a bit later. Okay, I'll write it here. So I'm going to normalize the data. All right, so I'm going to normalize the data on the data set. Okay. So to do that, of course, the easiest way is I'm going to get the text frame, okay, and I'm going to divide it from 255. So that will help me to get it normalized. Similarly, I can do the same for the X test, right? So I'm using this data set also for the testing purposes, and this is not needed for the Y. So I have to normalize only the X data set. Okay, that's fine. Then if you actually do a print, you can see you will not get this 255 values, right? So it's everything at in between 0 and 1. Right. So then, until the output comes, let me take you to the Keras neural network model. So you can check it from the same page. Yeah, so if you go to the sequential model, that's like the starting point of the neural network. So you can see there are different types of neural networks which you can create. So the first one is called the sequential model. And the next would be, so in the sequential model, you have to basically get these two imports done. And also then you have to set up the model. You can set it up in this way or this way. Basically you have to add layers, so you have to use 3 layers if you can remember. So basically you have the input layer, and then the hidden layer, and then the output layer. So we have 3 layers, so we are going to do work for these 3 layers. Okay guys, all right. So we might need this model, and if you want you can use other models, and also once you set up the model you can compile it. So for the compilation command would be this, right? We'll discuss about it, and you can train this, and then so if you use the command fit to train it, and then you can test it. And there are other models also. You can use multi-layer perceptron, so that's what we use, and then you can do binary classification, and you can use LSTM, and there are other models as well. So it's not that difficult to do as implementations. Theory can be a bit detailed, but implementation is not that detailed. Right, so now what I'm going to use is that so you can get so you can see the output. There's no bigger values, so it's in between 0 to 1. All right, that's done. Okay, now point where we build up our neural model, right? So as I said, first I need to get the Keras sequential model. So that's the first step. Sequential model. All right. So you have to first import those two. So you need to get these two. I'm going to copy this. That should go here. And I will use another tool here. So this is called flatten. Okay, that also I will import. All right, so that is done. Then I need the model. sequential model. So that also I can get it from here. So this is, I can copy or I can write it. So I don't have to copy it there. So what I'm going to do, I'm going to use that sequential model. Uh, so I'm going to say I'm going to use the sequential model. Yes, that's okay. Then what I'm going to do, I'm going to use, or I'm going to flatten that module. So the module that I loaded, so I'm going to flatten that. For that, I'm going to say get the input shape. So this is the input. Actually, it's like if you can remember, it's the image of 28 by 28 pixels. So what I'm going to do here, I'm going to, now it's a two-dimensional array actually if you load it. So I'm going to flatten it to a two-dimensional array, into a one dimension, into a one. So that's what I'm going to do here. Okay, so that's basically the first two commands. So, and also remember this would be the input, right? This would be the input layer. Okay, that's done. And then I have to add the, so these are the commands to add the layers. Okay, so model.add. So it's that simple. Okay, and the next one, it should be the hidden layer. So there's no exact rule how to develop this. So it's trial and error. So let's start with 20 neurons. That's a good number to start with. And then the activation function, we talked about the activation function. So there are different functions that we can use, but we'll start with ReLU. Later on, you can change these things. So we make a note that we start with, then later on we can change it, start with 20 nodes, right? And later on we can change it. And also this activation functions also you can change later. So that's the hidden layer. If you want, you can have two hidden layers as well. Hidden layer, and then you have to have the output layer. Output layer. All right. Okay. So I'm going to add the output layer. That also would be a dense, dense layer. And how many nodes you need now? This is you don't have to do a trial and error because this one you know exactly. So how many classes was there? If you go to the data sets, yeah. So you can see there were 10 classes already with the 0. Alright, so that's the model that I'm going to use. I'm going to use 10, and so those are the number of nodes, and the activation function which I specify we'll use here the softmax function. Softmax is more recommended. So yeah, so that's fine. So that's basically is our neural network. You see, like creating a neural network won't be that difficult. It's not a difficult task at all, right? Programmatically, it's quite easy to do. Of course, there are so much of things to learn about the theory of a neural network, but programmatically, it's not a really hard thing to do. So then I just wanted to get the so later on we learn how to get this as a TensorFlow model if you want to, but here we can get the model summary. All right, so that will give me the base idea of let me check. I have removed all the print statements. I don't need this. Okay. All right, so now I'm going to run this. So I want to check my neural network model whether everything is right. Okay, so if this is okay, so we are good to go for the next step, which is the compilation or the training of the neural network, or to give the properties of the, not training actually, it's due to properties of the neural network. Yeah, so basically you get your summary. So you can see the layer. First layer is input layer, which is flattened. So now we have 784, that is 28 by 28. And then the dense layer, hidden layer, 20 nodes, and then 10 nodes. And how many parameters altogether? 15,000 parameters. All right, so that's good. So now if you go back to the Keras, so you can see how to build a model. Yeah, so this is the yeah, we have developed the layers. So yeah, so now what we have to do is we have to compile the model. So where is the compile code? Yeah, so this should be the compile code. So when you're compiling, so you can do binary classification. So this is for binary classification. This is not what I need. I can use something like this single input model with the 10 class. Yeah, it's a categorical classification. So I can use something like this. Now this would do. So let me copy this one. Yeah. So thereafter I can get the dummy data. All these things are there. So I don't need that right away. Yeah, I'm going to copy this. So my optimizer is RMS prop. So there are few type of so this is like the RMS prop. Okay, so there are other options. I can use Adam also. If I want, I can use Adam. So I can first use Adam, then I can use RMS prop, which is there in documentation. So then we can check the accuracy levels later on, whether which one is better, right? And optimizer is that. So this is the gradient descent function. So if you wanted to like get some idea, there are different types of optimizers available, right? So there are plenty of optimizers available for you to play with, right? So if you need a list of optimizers, right? So let me give a list of optimizers which you can use. So let me find a list for you. So, oops, sorry about it. Okay, these are some of those optimizers: momentum, a diagrad, and RMS prop. So this we can use and see Adam, ADAMAX, AMS squared. So there are several optimizers to use. So remember, so this is very important. This is to find your minimum. So there are different types of gradient descent algorithms. So we have discussed about gradient descent algorithms. Okay, so we can change optimum and also loss function. So loss function is also important to keep the loss to a minimum. And then a categorical cross entropy is something that we can use, or there's another one. You can use something called sparse. Sparse categorical cross entropy, or you can use in normal gradient descent we use minimum squared error, sorry, not minimum, mean squared error. That's also you can use. So you can learn about these things later in the gradient descent lectures. You can double check that. And then the matrices, you can use accuracy and then messy, right? MAE, sorry, MAE. But accuracy would be the most important one that we're going to look into. All right. So this is basically a multi-class classification, right? So what I'm doing is not a binary classification; it's a multi-class or categorical multi-class classification model. Classification. All right. Okay, that's done. So I can compile this now. So this should build a model. and then of course I can do the training part. Okay, so now I'm going to do the training. So if you want to do the training, of course you have to use the function fit function. So I need to pass the x data and then the y data. Okay, that's all I need. Everything is fine. So this will actually start training. This will actually start training. So let me start my training phase. Okay, so you can see it will start training. It might take a bit of a time. I will let it run. Meantime, I'm going to complete the rest of the documentation. So you can see the epoch started. So a lot of data is being trained. So see 60,000 data elements are getting trained. So it takes some time also, guys. All right. So once it's done, it will say the loss is quite high, almost 50% are lost, and then the accuracy is 8060. So we'll try to put it down somewhere. Right? So copy. I will put it here. Okay. So basically, I have loss of. So this is where I use Adam, and I'm not going to talk about loss function. Yeah, so later on we can check with RMS prop. So the loss is 0.5623, and the accuracy is the next important one. All right, accuracy is 0.8060. So this is a very basic training phase, right? So very basic training phase. So we'll do some changes and see what will be the differences. So okay, I got the model. Now what I'm going to do is I'm going to predict this, right? Before I predict, now I have the data, so I can check with the model now. So let me check with the model. So again, I will use the match show, and then I'm going to use the test data set to test this. I'm going to first test the first element. So let me run this. Take a bit of a time. So then once I find out what would be that output, okay, I have to see the output. No? I have to see the output. So it can be a shoe or it can be anything. So we see what is the output, and then what we can do is I can predict, right? Predict this. What is it, right? So to predict it, I'm going to create a variable. I'm going to use the predict. So I'm going to pass the test data set, and then I'm going to yeah. So I'm going to print yp-0, so I can check how is the result. Okay, let me check this now. Okay. Okay, what's the problem? Okay, there's no dot here. Okay. So let's check. Might take a bit of a time. It's all right. Okay, it's training. Okay, I got a boot. So if you can remember, boot is 9, right? So they didn't call it a boot. They call it as okay, of course, sneaker boot or something, right? So then we'll wait for the output, which is YP. What is it? So we'll get that. Yeah, wait for the output. Until that, what I can do is I can get what is the correct value. For that I'm using, take a bit of time it seems. I'll close this. Yeah, so now this is the printing of that array. So as you can see, okay, I'll do a print here and try to get the NP argmax. So then from this array I can get the largest value. So that's much easier. You can understand whether my prediction is right. Okay, so as I see, so let me run this. Meantime, I can check again. Sneak a boot. So if we go to the data sets, that's data sets. Okay, all right. So yeah, so the anchor boot is 9, right? This anchor boot is 9. So we'll see whether we get it right. So by printing this, whatever the largest value, the index will be printed. So let's see whether it's working fine. So wait for the input as well, image as well. Yeah, this is anchor boot. So it should be 9, right? So we'll see. Oh, okay, I didn't print this one. This is my bad. So I have to print this one. Okay, so again we have to run this. Okay, so until it loads up, we'll try to, okay, so that's one other thing that we have to type in. So we have to get the evaluation also of the model. Okay, so to get the evaluation of the model, accuracy levels are given here, but I need the proper evaluation of the test set, right? Not the trained data set. So to do that, I need the X test and the Y test. So we'll get the output of that test here, so you can get a good idea. Now this is manual testing with this example, the anchor boot. So let's see the value. Okay, so see, 9 is the value. So the max is on 9. So my model works perfectly right at this phase. So let me get the evaluations also. So because this is important for further tuning my model, right? So before I'm going to tune, I'm going to learn a bit about these two things, like what you can learn about the epochs and iterations. Let's check whether we get some. So we'll wait for the output of this. Yeah, so it's working. Okay, so the anchor boot, I can remove it the next time. Okay, I have to print this side. Yeah, I have to print this. Let's run this again. So until this loads up, let me go to the whiteboard a bit. So try to now, if you try to understand what is a epoch. So basically a epoch is when you have large data set, this is important. So epoch is when the entire data set is passed forward and backward to the neural network. So you have the neural network, right? So your data set is passed back and forth. So that's called an epoch, right? So you might need more than one epoch. So where you get better results, of course, better accuracy and all that. So it's recommended to have more than one epoch, right? So these data we can feed in and see what would be the output. And also sometimes we are not supposed, or we cannot basically train all our data at once. So in that case, we might need to do a batch processing. So you can set up some batches as well. So that's where you need the epochs and batches. And once you run one batch on the one epoch and whatever the number of epochs, that's called a one iteration. So and also apart from this epochs and batch sizes, you might have to basically work with your learning rate, the LR, and other parameter tunings, right? So that's also is needed when you want to model your data, right? And also, especially when you deal with epochs, too much of epochs would also, okay, my code is running line. Now, close this. And also, too much of epochs also would be hurting you. So you have to have a kind of a model in between. So as an example, so you have too much of epochs would overfit and then or underfit. So you have to have the optimum setup. So say you can use 20 epochs. So likewise, you can have a kind of a rough number and then you can work on that. Right. So that's how all things work. Yeah. So let's now see how to do a bit of a changes to our model. Okay. Okay, so this is the model summary. So what you see in the first one is the lost, second one is the accuracy. So this is basically what I have write down earlier. So it's the same thing, right? 5623 bit different, but it's almost the same. So I'm not going to write it again. Now what I'm going to do, I'm going to change some of those properties. So if I want to change the batch size and the epochs, I have to go to the fit function. That's my fit function here. Before, after I give the data set, I can give the epochs as 20. So it's a good number to start with, epochs 20, and the batch size, normally we can give something like 120. But remember, so when I add this, it might take a long time to process this now, but we'll try to do it and see. So we'll check for the output. So that's one change that we can do. Right? So then we'll see what about our accuracy levels, how I would change the accuracy level and the loss values. At the same time, I will be able to, I'm 100% sure that will take a long time, but if I do a bit more, so next loop I'll check it. If I check with 50 nodes in the hidden layer, of course that also will improve the accuracy, but I have to wait and see. Okay, so that will be the next iteration. So we'll wait and see what would be the loss and the accuracy of this. All right, there's a small issue. No, it's okay. I know. Okay, I think that was a mistake when I did. Okay, I might have to change this again then. So this was dash 20, so I will leave it like that. What's the difference? So epochs. Okay. So EPOCHS 20 batch size. Okay, that's almost done. Then run it again. And we In the meantime, let's check something interesting. Probably you have seen this before. Uh, we can go to the TensorFlow playground. Actually, TensorBoard playground. Okay, now if you go there, now we have built our first neural model. So we'll wait and see how it gets represented in TensorFlow playground. So my net connection is a bit slow. So it's loading. Yeah, so what you see here is something very similar of what we have done. So it's also a classification, is it classification problem? Yep. Okay. The classification problem, we haven't changed the learn rate, but activation function we can change. We used ReLU, right? Of course, you can change it to RMS prop also. You can see here you don't have RMS prop. You can use it there. Sorry, we can use it more than any other. And then regularization, we haven't discussed it, and then the classification. So we had some layers here, and there are actually more layers in our hidden layer, actually more nodes in hidden layer. We had 20. So you can run it and see time it takes to classify it. So it doesn't take a long time, right? You can see the loss accuracy is not displayed here. So play with this, so this can give you quite a good idea about what's happening around. So let's check our output. Right, still okay. Sorry, there should be a oops, that's bad. Right, going back. Okay, so likewise, you can do a lot of changes according to your needs. So here, this of course a binary classification, so two neurons only needed. If you have more than multi-classification, you might need a different one. Okay, now there's no error, so we'll wait and see. So remember, there are so many different types of exercises that you can do with this. It's quite interesting, right? So the epochs are starting. So you can see now epochs are running in different iterations. You can do those experiments. So one thing you have to understand, you have to be very patient when you deal with machine learning. Sometimes, so see this, there are 6,000 images, but these images are quite small. But think about you're running really big images, it might take a very long time. All right. And also I'm running in a normal CPU in my MacBook, even this is MacBook Air. So if you have a GPU, you can kind of make this process faster, much faster. Okay, it's still running. So I will not do all the changes. You might have to do it by yourself, and you can see how different results that you get. You can change even this one to RMS prop, so there will be definite improvement in your model. So I'll post this video and come back once done, otherwise you're just wasting your time. Okay, so it ran and then you can see the improvement. So previously it was loss is something 0.5, now it's improved to 0.38. So, and also the accuracy also improved. So you can do all these changes and see how things are improving. All right, so hope that you got an idea about how to do a neural network model. So the next time we are going to use a more advanced neural network, and we'll do a different type of problem, solve a different type of problem. So please try to practice this and do some experiments with some coding, right? And also try to change these modules, different types of gradient descent algorithm, optimize algorithms. So you try to do those changes, right? So that can be quite important for you to understand the rest of the things. Okay, and yeah, so all right guys, so we'll see you in the next lesson. And also make sure to continue the project work. So I need a kind of a progress of your project work very soon. All right, thank you.